If area and perimeter was a piece of cake, volume is a piece of cake. If area and perimeter seems still a little tricky, then volume is going to be a little tricky. Finding the volume of three-dimensional shapes. Why? Because they all follow the same formula, the same routine. You pretty much use the formula, plug in the info, and then solve for the volume in this case. But before we get there, let's recap on a couple stuff. So, last week we went over area and perimeter of 2D shapes. Those were a couple 2D shapes that we had. And obviously when it comes down to two-dimensional shapes, all we deal with is area and perimeter. Now we're moving on to three-dimensional shapes. A three-dimensional shape, how can we explain this? It's pretty straightforward. If you look at this little cube there in the two-dimensional world, you are just seeing one side of the cube. The moment you decide to, go around it and just to eye it up and down, you end up seeing its multiple sides. You end up seeing its left side, its top side. You assume there's a right side and a back side and a bottom side. You see all sides to that one 2D shape. That is what makes it 3D. So if this was a square, what is this three-dimensional shape called?
Cube.
A cube, right? This is a rectangle. You might call this a box. But in math lingo, it's called a rectangular prism. Rectangular prism and... that's ugly. A rectangular prism and cube use the same formula, which is why those of you that have that GED formula sheet still, hopefully you do, it's your best friend next to the calculator, you would see under the 3D shape, under the volume formula I should say, it doesn't have no volume of a cube, it just has a volume of a rectangular prism. That's because they are both the same. They use the same formula. Let me pull this up very quick. So let's look at this right here. We are looking at this section right here, my friends. We are looking at surface area and volume of A. They give you the surface area and the volume of each shape. We today are just going to be using this section here, the volume section. Tomorrow we'll be doing the surface area, but hint hint, it's all the same thing tomorrow as well. We just got to take stuff little by little. Okay, so we're going to be looking at that section of the formula sheet. But yeah, if you notice, all it says is rectangular prism. I think yours might say different. I don't think it has right prism, rectangular / right prism. Right prism should be its own formula, I believe. Is that correct on your guys' formula sheet?
Yeah, it's listed separately.
Okay, it should be listed separately. This one's a weird one here. But if you notice, all it does say is rectangular prism on your guys' formula sheet. That's because, again, the cube is the same as the rectangular prism. So, let's practice our skills. What other 3D shapes do you guys see in that formula sheet? Let's try to draw them out. What's a couple that we see or know at the top of our heads?
Sphere.
Sphere! All it is really a ball. They just show little lines to indicate space inside. So that's a sphere. What else do we got?
Pyramid.
Good, good. We have a pyramid. What else? I'll give you its counterpart, the cone. It's all there in the formula sheet. What's another one? Three-dimensional shapes. Can somebody tell me which one's that one? That one's called? Cylinder. For those of you taking GD, they love throwing cylinder questions at you. They love it. Cube, rectangular prism. There's that. A right prism. That's pretty much... It kind of looks like a tent. Don't get that confused with a pyramid. A pyramid goes to one point. Right prism, again, it's pretty much two triangles. You kind of see it length out. And I think that's everything. Okay, cool. So, there's a couple three-dimensional shapes. Do we remember our step-by-step guide to solving any shape type of question? You got to find out what they're asking, what they're looking for. You got to know what shape is in front of you. And you got to go hunt down for its formula. Plug in the stuff into its correct spot in the formula. And then solve. So let's begin with the easy ones. Easy ones being those rectangular prism ones. Actually, let me try to draw the one that I have here. Let's see how good of a drawer I am. Actually, I'm too lazy to draw. What the thing had was a little box there. Like that. It was pretty much a box. That's what the box is. Okay, and we had a couple measurements. We had 4 there, we had 5 there, and then they give us this here. The question is this. The question is, Neil is moving out of his 5-story home in Mercer Island. He's ordered a couple boxes to be sent to his house. The boxes that they send measures 4 feet by 5 feet by 3 feet. Big boxes.
I don't know if you could actually live inside of.
Right.
Grow up. You could live inside of those.
So 4 feet by 5 feet by 3 feet. Good. The question is this. Neil has a whole bunch of stuff, and he wants to know how much space inside each box holds to measure the stuff that he needs to put inside to move accordingly, right? So, how much space does each box have? What are they asking there?
How much is the volume inside of each box?
Yes, so, well,
I'd say
what,
about 6
hold
feet.
on. We'll get through the math part. Let me explain first. So, volume. That is what volume is, my friends, if you did not know. Volume is the space inside the three-dimensional shape. The space inside a three-dimensional shape. They are asking for how much cubic feet inside this box. How much space does it hold inside? That is what volume means.
I'd say 60 cubic.
By the way, well, I'm not going to mention what surface area is. We're going to do that tomorrow. So no need to even go over that today. But you could probably guess what surface area is, honestly, if we know what the volume is. Volume means inside, the space inside. So, my friends, you've just determined what they're asking for. They're asking for the volume. Do you know what shape this is? Well, like I said earlier, it's a rectangular prism. It's a box. So now that you know what they're asking for, now that you know what shape it is, what's the next thing you got to do? You got to find and write down the formula of finding the volume of a rectangular prism. Tell me, what's the formula?
Length, width, and height.
Volume equals length times width times height. Is that correct? Perfect. So, what is the length? What is the width? And what is the height? This is where it always gets confused, but it doesn't really matter because it's all multiplication. You could have the length being the 4. Sorry. You could have the length being the 5. You could have the width obviously being the 4. And the height being what they gave us, which is 3. Just like we did last week, there is no difference. All you do is plug in the info that we are given into its designated spots, and then you solve. What is 5 times 4 times 3? Volume equals 60. 60 cubic feet, 60 cubic inches. That never matters, trust me. You're just looking for the one that has the 60. That's how much space it holds inside, which means you cannot put 60 cubic feet worth of stuff inside of this box. So now let's turn it up a notch using a formula that isn't so simplistic as length times width times height. Let me give you this. Okay, so here's the word problem. A farmer has a couple water barrels that collects rainwater, right? They're old, so he throws them away and he buys these new barrels. These new barrels are shown in the figure below. He wants to know how much water his new barrels can hold. Figure it out in whatever minutes, whatever the question might ask, right? So, what are they asking for? Again, they're asking for how much water the barrel holds. So what are they asking for there? What do they want you to find? Again, space inside, water inside. That they're asking for the volume. Now, all they said here was a barrel. Tell me, what shape is this?
Cylinder.
Cylinder. So now that you know what shape it is, now that you know what they're asking for, the volume, again, you go hunt down for the volume of a cylinder formula, which is what?
Radius.
No guessing. Everybody look at their formula sheet and tell me it.
Formula sheet.
I gave it to you last week. I'll give you
I
one.
never got one.
I gave it to you. I'll get you one. You know what? Who needs a formula sheet? Do Dios, no surprise. So I heard a pi.
R to the second.
Thank you. And is that really it? Is it really that simple?
Height.
Duh. Times height. Okay. So there it is. So now let's fill in what we know. Volume equals, what's pi?
3.4.
Yup. What's my radius in this given situation? That's right, 2D stuff creeps into 3D stuff. Do we know what the radius is? Or are you kind of confused by why they're even mentioning this? Well, look at it carefully.
It's
What is the shape? What is the shape that involves pi and radius and diameter and all that.
Circle.
Circle. What shape does this cylinder, this three-dimensional shape, have for its base and its top?
Circle.
Circle. You kind of have to like look at it as if you were viewing it at the top, and all you would see is a circle, right? So, in this specific case, what is the radius if they gave it to us right here? Well, kind of right there. They gave us the diameter for the given circle. If we just saw this from the top view, all we would see is this, 6. And do we recall what the radius is? It is half of the diameter, which means half of 6 is 3. So it's 3 squared times h. And what's h in this specific case? Height, which is what? 8. Now that you've filled in your formula, get out them trusty old calculators, punch all of that in. 3.14 times 3 squared times 8. Oops, I got no calculators.
226.0.
Volume equals, what is it? 3.6?
226.0.
226.08. Anybody else get something different?
Nope.
All right, so 226.08 cubic feet or inches, whatever, of water. That's how much this barrel holds. It's the same routine as finding the area and perimeter. You just got to fill in the formula with the correct data. There's just one tricky thing that you could see in the formulas, the right prism and the pyramid. There's just one little variable that you need to learn. Tomorrow we'll learn some more variables that formulas give us. But for now, we're just going to go over 1. 7, 3, 3. Okay. What shape is this?
Pyramid.
I want to know how much space it holds inside. So, go look for the volume of a pyramid formula. And what do we get? What is it? Volume equals what?
1/2.
1/3
Is it?
base times height. Okay.
Oh, yeah.
So tell me, just like before, let's fill in our formula with the given data. Volume equals 1/3. What is my base?
That's width times length, so it's 9.
It is 9. And what is height?
7.
So this B, this base, is what I want to explain first before we go on. You could solve this probably, but I don't care for that right now. What I care for explaining how we got 9. Look at it. Well, actually, this just goes in general for all the other shapes, for all the other formulas. Base in three-dimensional world means the area of the bottom shape. If we were to hover over this pyramid, what would we see? We would see a plain old square. That looks kind of like a rectangle, but it doesn't matter. It's a square. That's what we would see for its pyramid as a top aerial view of this pyramid. And if we knew this length was 3 and this length was 3, what is the area of this shape? Well, we know it's a square. You just have to get 2 sides and multiply it. 3 times 3 being 9. So when they say base, they mean, in the 3-dimensional formulas, not the 2D ones, right? In the 3-dimensional shapes, when you see the variable b, that means base, that literally means the area of the bottom shape. In this case, you had to multiply the two 3's to find the area of the square, which ended up being 9. Yeah, tomorrow we'll go over the P and the S and all that. But for now, base. That's the new one. You need to find the area of the bottom shape. So now, tell me, 1/3 times 9 times 7. What do we get as the final answer here?
21.
21 exactly?
Yep.
I'm awesome. I created that problem at the top of my head. Came up with the whole number. I knew that. So, my friends, does anybody have any questions so far? One last note, just like when we were doing the Pythagorean theorem, remember the Pythagorean theorem? Does anybody remember the formula? A squared plus B squared equals C squared. Do you remember what that is used for? You're gonna have to know though. You're gonna have to know this question. Hint, hint, wink, wink. What is the Pythagorean theorem used for? To find the missing side of a right triangle, right? So we were always practice like that, like that, like that, because that was easily a right triangle. You could visibly see it. But then you would get tripped up, or not all of you, but you can get tripped up if they were to flip that shape on its side, right? Your A, you get distraught. You no longer know where the C is. You no longer know where the A and B is. For a split second, you have to really view it, and then you're like, oh, okay, no, I know what it is. But that's what happens with shapes. When we're so used to learning something at a certain way, and then out of nowhere, when they do some small little change, it trips us up. Don't be surprised if they give you a cylinder like this, right? And then they give us the radius of 3, and this one's 9. Some students think if the volume of a cylinder was pi r squared height, 3.14, they think that the h is the 3 doubled, pretty much the diameter, which makes logical sense, honestly. They think it is 6, so they put the 6 there, and then they think by default the 9 is the radius just because, right? But no, it's just a cylinder that happened to get flipped on its side. Don't let that trip you up. Don't use common sense. I know you would think the actual height would be vertical, right? But think of this as if it was like this. The 9 is the height, and the radius is 3. Don't let these three-dimensional shapes, when they put it on its side, or when they decide to tilt it just a bit, don't let that be the thing that trips you up, all right? You're doing the same thing always. You're locating the formula, you're punching in the correct numbers in, and then you're solving. That being said, we are good to go.